Hello friends, welcome to this interesting session of what is Spark from Edureka. Let's move further and see what is Spark, what you can expect from this course. So first you can expect that you will understand why Apache Spark, why we are learning this technology Apache Spark, what are the features related with Apache Spark, what all the components we have in Spark ecosystem. Then we will do some hands-on example, and in the end we will also move to the use case portion. Now, so let's talk about big data analytics first. What is big data analytics? Point number one. Now, everybody of you must be knowing Facebook, Twitter, Instagram, a lot of different variety of things what we have. Now, you might have seen that if we talk about Facebook, how old is this Facebook? Almost 12 years old, right? 10 to 12. That means it's not like a very old company like Oracle, Microsoft, or Google. So these companies are very old, like 40, 50 years old company. But this company is just 10 or 12 years old. But there was a fun fact, which CEO of that company, Mark, have quoted this assignment. If you go just 3-4 months back, you will be able to see that fun fact from Mark. What he mentioned was, today the number of people who are using Facebook is equivalent to the number of people who were living on this earth 100 years ago. Again repeating it, today the number of people who are using Facebook is equivalent to the number of people who were living on this earth 100 years ago. Don't you think it's a big statement by Mark? And don't you think it's a huge data he's talking about? In last 10 to 12 years, they were able to generate this much of huge data. Now, what you usually do on Facebook? Now, with number of users itself, it is sounding like it's a huge data. But what you generally do on Facebook? You post something, very good, isn't it? So, you upload videos and images, very good, right? So, when you do video or images and all, what kind of data is this? Can I keep this in the category of structured data? Does it have any sort of pattern-oriented data? No. So which category it is? Unstructured. Very good, Rahul. Right? So this is going to be unstructured category. So I'm creating a new category for it, unstructured, because this data do not have any sort of pattern. And this data is huge, right? Because if you compare this data, like when you have any images or video, they are usually in a bigger size. So this data is huge also. Now imagine so many users, and each user is doing some sort of upload, some sort of posting and all. And imagine the data what Facebook it might be dealing with, right? So Facebook is dealing with such a huge amount of data, not only in terms of number of users, but also in terms of what the data each user is generating for Facebook, right? So this is just one example. Now we can also say per minute activity. If I talk about Facebook, almost you can see that such a huge number, 41,66,000, right? That's a number for it. That's such a huge number of likes happen on each post, right? For the post level, this number of likes happens. If we talk about Instagram, so many posts happens every minute. If I talk about YouTube, YouTube has such a huge amount of data. If you kind of sit and want to just see all the videos of YouTube, and that one I'm talking about only today, the number of videos which are available on YouTube. In fact, we little surprised to know that in that case you will find that almost you will not be able to finish this definitely in this, not in this lifetime. Okay, so you will be taking so much of time to finish them up just to see all the videos. Imagine the amount of data what YouTube have, right? Even the founder of that YouTube, if he wants to go and look at all the videos which are available in his site, it's impossible for him to do that. It's impossible. That is not in this lifetime he can do it. So every minute, 300 hours of video is getting uploaded. Imagine with the pace the data is also growing up. If we talk about Reddit, so many users, 18,327 votes happens every minute. Twitter, 3,47,222 tweets happens every minute. So much of big data we are talking about, right? Which is getting generated every minute. Now, what happens in your big data analytics? In your big data analytics, what generally happens, let's say with respect to time, there are two things, right? So if you notice here, so you will try to find out some sort of pattern from your data. So let's say I give you any data and say that, okay, does this data making any meaning for me? Until and unless I go and analyze something, I will not be able to make out any meaning from it, right? So I want to get some hidden patterns from my data. I want to find out, okay, if there are, let's say, multiple variables present in the data, is there any relationship between those variables what we have? Is there any customer prediction what I can do from that data, or any sort of useful information which I can make from this data? Okay, so that is what we do in our big data analytics. So we try to predict something. Now there are two kind of ways we can predict. One way is we can store the data from beforehand itself, and then we later do some prediction and give it to the client. Second way is as and when the data is coming, at the same time we start doing our analytics and give our output. So these kind of analytics, that the first one which I said, okay, I can store the data and then do some analytics, is called your batch time processing. And the second kind of thing where I'm doing at the real time, means immediately as and when the data is coming up, I'm performing something. This is called as real time analytics. Okay, so the second type is called your real time analytics, where as and when the data is coming, we are doing some processing. Just to see some examples, you all must be using washing machine in your home, right? Now, what you generally do when you have to put your clothes in washing machine, you collect some clothes and then later you process it, right? That's a general thing what you do. Now, whenever you do this, means you are collecting the data and then you're processing together. That kind of analytics, when what you're doing in washing machine, is called your batch time processing, where you are doing work on your historical data. Second kind of analytics, which is a real-time analytics, which means like as and when the data is coming, immediately I am doing the processing on top of it. So that is the kind of analytics we will be calling it as real-time analytics. Okay, so that is the second analytics. Where, okay, just to give you an example, you can take up a bank where, let's say, when you do any transaction, they want to identify whether it's a genuine transaction or a fraud transaction. Do you think they can store the data and can they later find out that, okay, it's a fraud or non-fraud? No, right? So definitely they want to immediately find out all these things. And this kind of analytics, we call it as real-time analytics. Now, in Hadoop, we can only do the batch processing. Real-time processing is not kind of possible in Hadoop. But when we talk about Spark, real-time analytics is also one of the added functionality. Question from Rahul. Okay, so in that case, Spark cannot perform on batch analytics? No, it can perform on batch analytics as well as real-time analytics. So this is how you can do it. Now, let's see a few more examples of it. In banking, I just gave you an example, whether they want to identify whether it's a fraud transaction or a non-fraud transaction. Government-based systems. Now, if you are in India, you might have seen that India is trying to move towards now cashless economy, right? Now, government have came up with a lot of apps, like for example, BHIM app. You might have noticed all those apps. Now, they have also came up with something called as you can do the payment with Aadhaar card, right? Now, in that case, don't you think it's very important for government to do an immediate analysis? Because let's say somebody is putting his Aadhaar card, immediately his data need to be processed and need to be find out whether he's a genuine person or not, right? So in government agencies, in a lot of places, real-time analytics is used. In healthcare domain, it's very important because here the patient, it's all about life and death, right? So we cannot take the risk. So let's say any patient wants immediate blood, right? So in that case, immediately it should happen in the real-time analytics that this broadcast the message to all the blood bank people so that they can get it and immediately they can respond back. Similarly, telecommunications. Here, let's say the call drop and all those things, what's happening, they want to analyze with respect to real-time analytics. In stock market, it's very crucial because stock markets, every second, things change. So now we want to predict whether the share is going to perform good or bad in next second, right? So all these things is only possible with real-time analytics. So our requirement is that we want to process the data in real time, not possible in Hadoop, but it is possible in Apache Spark. We want to handle the input from multiple sources. It is possible in Hadoop as well as Apache Spark. And your Spark is very easy to be used and not with Hadoop, because Hadoop, if you have done any programming in MapReduce, I need not tell you that in MapReduce sometimes things works very slow and it is little complicated to understand, especially for a fresher. Learning MapReduce is not a cakewalk. That's the problem with Hadoop system. And even the last thing with fast processing is that Spark provides a better performance in comparison to MapReduce. In fact, it may perform 100x times better perform in comparison to your Hadoop type systems. Now, what is Spark? What is Apache Spark? When we talk about Apache Spark, first thing we have just understood that real-time processing is our main motive. Means that's not the only motive, but yeah, that's definitely one of the advantage what we have got with our Apache Spark. So it's an open source cluster computing framework for performing your real-time processing, and it is developed by your Apache software. Now it provides you the facility to do your data parallelism, where you can actually perform all your computation in parallelly, and everything is going to happen in memory. Even though everything is going to happen in memory, but still it is going to be fault tolerant. Now all the computation you are doing in memory, but still Spark will ensure that you should not be losing any sort of data. That is one of the important thing here. It is built on top of Hadoop MapReduce, so it doesn't mean that it is going to replace MapReduce. It is a kind of a complementary thing with MapReduce, and yes, a Spark is able to replace a lot of jobs of MapReduce in many applications. A lot of companies have started moving from MapReduce to Apache Spark for various reasons because they want better performance, but still it doesn't mean that it is going to kick out your MapReduce from this. Okay, it will not be able to kick out MapReduce from the scenario at all. If we talk about why Spark, you can write Spark in using various programming languages. One can be Java, Scala, Python, R. These languages are currently the supported languages. Now, Spark is, as I said, it can give you performance even 100x times better than your Hadoop system. It also have a powerful caching, and you can deploy it with Mesos, Yarn, or even it have its own standalone system. Anil is asking a question, can I write this in PHP? No, currently PHP is not allowed. It is allowed in only 4 languages: Scala, Java, Python, and R. Though the motive is that in near future, all the programming languages will be supported for Apache Spark, but currently only these 4 languages are supported at the moment. Let's see some success stories of Apache Spark. What are the use cases we can use also? In Twitter sentiment analysis, that's one of the very important topic here, because here using Twitter, now let's say if anything is the trending topic and you want to kind of use that and want to do some analysis on top of it, you can do that. So that sort of analysis you can do with Apache Spark. I just talked about an example of stock market. Stock market, we let's say want to predict that how this share is going to kind of perform in the next few seconds. So all these things we can do it with the help of this. Banking credit card, I just discussed about this also, that here bank want to identify whether it's a fraud transaction or a genuine transaction, right? So all these things bank want to identify. Genome sequence, again, in the medical domain, it's very important to kind of use Spark analytics with various kind of use cases possible. Now let's see how we can use Hadoop through Spark. So when we talk about it, Spark can run in multiple modes, like Spark with SDFS now. So Spark can run on top of SDFS to leverage the distributed replicated storage. Now, if you want to, let's say, have your distributed replicated storage, you want to also have your replication along with it, you can use SDFS. So Spark can also run standalone. Okay, question from Nitin. So Spark can also run without HDFS? Yes, definitely. That's what I was just answering that also. It can run without SDFS as well. So but if you run it with SDFS, you can leverage the distributed system. You can also leverage the replication. If you're running it, let's say, on your local system, then you cannot leverage all that replication factors and all, right? That's the only thing. Now, when you run Spark with MapReduce, Spark can be used along with MapReduce in the same Hadoop cluster as well. Means if you have already created a cluster for MapReduce, you need not change your cluster just to run for Spark. We need not do all that part. When we run with Hadoop Yarn, Spark application can also be run on Yarn. So that's one of the very powerful property, because Yarn is the most widely used cluster resource manager, and we want to make sure that Spark can also execute with that. Now, with MapReduce, we have just discussed. So if we work together, right? So sometimes it also happens that we are working Spark and MapReduce together. So in case if we do that, so we can also perform our batch processing as well as real-time processing. So maybe some part of the problem we can solve it as a real-time processing, and some part of the problem we can also solve it as a batch processing. So this is also possible to do. What are the features we have in Spark? Number one thing, speed. Speed, if we compare with respect to Hadoop, definitely if we use Hadoop, let's say, to solve some problem, it takes, let's say, 171 kind of seconds. Now I'm talking about an example of PageRank. So let's say we have created a PageRank and executed it with respect to Spark. We have done it with Hadoop, and we have done it with Spark with respect to some partitioning. Then what is the difference which came out for us? So first thing, when we did it with respect to Hadoop, you can notice that it took almost 3 minutes, right? And that is a good time, means it's a huge time I'm talking about here. But when we did with Apache Spark, it took almost around a minute, 1.5 minutes around that time. That's still better than your Hadoop system. And when I used Spark smartly, we did it in just 23 seconds. Very good, right? Nothing can be better than this. Now, it can also support various multiple data sources. So it's not restricted to only one or two like text file and all. It can also take care of your JSON, Parquet, Hive data, Cassandra. From multiple data sources, you can get the data in Apache Spark. It follows lazy evaluation. Lazy evaluation says that till the time you do not want to print the output, you will not be performing any earlier step. That is a lazy evaluation. So this is one thing which it will do. Now the last part is real-time computation, which is we have just talked about that we can do real-time processing. So it also do it in the low latency, means it is very quick in terms of output because everything happens in memory. Now, this we have already seen that Hadoop integration with Apache Spark, so you can do it with HDFS, you can also do with MapReduce. Now, if you're executing your machine learning, you can be actually quick. So earlier days, what used to happen was that the MapReduce was the programming what we used to use, right? So in MapReduce, because MapReduce was slower, when you used to do machine learning algorithms on top of it, it is called Mahout. So you used to do it with Mahout. And Mahout was very, very slow in nature because the machine learning algorithms are complicated in nature and they kind of do a lot of iterations algorithms. Now, with respect to Spark, now Spark provides faster computation. So that is the reason if you use now machine learning algorithms with Spark, though it is iterative, but still you will get a very fast result in comparison to what you were doing in Hadoop. And that's the reason Mahout is going to be deprecated. It's almost deprecated because all the kind of core contributors to Mahout have moved towards Spark. And in Spark, wherever we use this machine learning, we call it as Spark MLlib. Okay, that's the thing with respect to this. Now, Spark components, we have multiple components: Spark Core, Spark Streaming, Spark SQL, MLlib. MLlib is for machine learning. GraphX, where you can perform your graphics computations, like you will be able to kind of create some sort of graphs and then compute. For example, you can see Google Map, right? So Google Map, when you do, it can use graphics kind of thing. Now, similarly, when we say about Spark Core is about just the general RDD. When we say Spark Streaming uses the real-time processing. So it's because of Spark Streaming, real-time processing is kind of possible. When we talk about Spark SQL, this is generally for a SQL developer, where you can write a query in a SQL programming and it will be getting converted to your Spark way and giving you the output. And since it is not converting to MapReduce, it is getting converted to Spark way, it is going to be faster. Okay, so that is what's going to happen there. Now, this is same stuff what we just discussed. In Spark SQL, it is mostly for structured data, where you will be performing a SQL query. Spark Streaming, which is for your mostly to use for your analytics and all, and it will be for real-time processing. MLlib is for your machine learning. GraphX, again, as I said, just like example of Google Map, you can use GraphX there. Spark R is an open source language, and it is mostly used by analysts. It is used by analysts these days, and R is very popular among analysts because it's an open source. And now, what Spark community decided was they want to bring up all those analysts to the Spark framework. Means if these analysts are, let's say, using or working on a big data environment, in that case, also they should be able to do it on Spark framework. So they started bringing this Spark R because of that. Now they will all be running on top of Spark Core Engine. Spark Core Engine is the one where all the basic functionalities of RDDs and everything are defined. Now, Spark components, again the same thing. When we talk about Spark SQL, we will be working with respect to data frame. Data frame will be SQL kind of data, what we are going to have. So it is going to be our data frame thing. Now, Spark Streaming, again the real-time processing. MLlib pipeline will be used for your machine learning. Okay. GraphX, again for GraphX and Spark will be using anyway the RDD way and their own way. So we will be seeing that in future. So let's talk about Spark Core. Now, Spark Core, if we talk about what happens here is, Spark Core will be having the basic information of RDD. So RDD is nothing but a distributed data which is sitting in memory. that will be your RDD. Now here, when you execute everything with respect to Spark core, you will be doing it to execute those things parallelly, and also you want to kind of distribute it in your environment. Now let me give you an example of how RDD looks like. So let's say in this case, I have, let's say, these two data nodes. Let's say these two data nodes are there. Let's say here block B1 is sitting. Let's say block B2 is sitting. Now what's going to happen? Using Spark API, you can bring this B1 block to the memory of this data node. Using Spark API, you can bring this B2 block to this memory of this data node. Now, as soon as you bring them together into memory, because they're sitting in a distributed fashion and all, they will be called now as a RDD. Whatever name you have given to this RDD will be created. So now you can see this is a distributed data, right? So that's the reason it is called as resilient distributed data. Okay, so this is your RDD, where the data which is sitting in a distributed format into memory, this is called your RDD. Now, RDDs are going to be immutable. Now, let's say on B1 block and B2 block, you did some kind of processing. Maybe you want to convert B1 block and B2 block to an uppercase. Okay, let's say you don't want to now no more work with a lowercase, you want to convert it to an uppercase. Now, since you want it to be converted to an uppercase, now, first of all, you will not be able to update B1 and B2. That means you will be creating a new RDD called new block called as B3 block here, and you will be creating a new block as B4 block here. So what happened? This B3 and B4 will also be created directly in memory itself. You are not going to do any sort of input-output operation here. So from B1 block, B3 block got created. From B2 block, B4 block got created. And what happened in this case? These two things, B3 and B4, which got created here, will be called as another RDD. Okay, so this will be another RDD which you created from your B1 and B2 block. Okay, so this is B3 and B4 will be combinedly called as other RDD. So question from Anil, in that case B1 and B3 are residing together in memory? Yes, they are sitting together in memory. How come we can stay two blocks together in memory? Okay, let me ask you one question. Right now you are running this GoToWebinar, right? It is occupying some space in memory. Now I am using this PPT also. Don't you think this is also occupying some space in memory? Now I am also using the chat box to see what you are typing in chat. That is also occupying some space in memory. Can you see multiple things are staying together in memory, right? Same way I can keep number of blocks also. Got it? Great. So this is how we will be keeping. So this is called your RDD, and this is how you keep the data. So when you convert one form of RDD to another form of RDD, like you have converted B1 block to B3 block, this step is called transformation. And let's say when you want to output the result, let's say you want to print the result to your console and all, the result of B3 and B4 block, this step is called action. Okay, so this step is called action, and the earliest step was called your transformation step. Now one more very important thing here, as I was discussing about that it is a lazy evaluation. Then what is a lazy evaluation? Till the time you do not hit an action, no transformation step will be processed. Okay, so that is what your transformation step is. Now, so this is all about your RDD understanding. I hope now everybody got clarity. Okay, Nitin is saying awesome. Great. Now, Spark 4 engine, as I said, you can work parallelly and you can work in a distributed fashion. So it will be helping you for fault tolerant. Now, how it is fault tolerant? Now, because we just said that we are going to keep the data in memory, how come it is fault tolerant? Let's say these are my data nodes, right? And my B1 block is here, B2 block is here. Now I am keeping it into memory. How come it is fault tolerant? Now look at this part. Remember our replication factor? We have our replication factor. So let's say I have one more data node where B1 and B2 are also there. Let's say this is my replication factor. Now in this case, let's say this machine fails. What may happen? This B2 will be immediately moved to the memory of this machine. And that's how it will ensure that you are not going to lose the data. So though you are keeping in memory, but still it ensures that it is going to be fault tolerant. So you can schedule your things, you can distribute it, you can monitor your job, you can also have interacting with the storage systems and all. Everything is possible here. Now, architecture of this. So first thing, very important part, I was discussing this thing that you are going to keep your data into memory and all. But before that, one more important point. Like in Java, we have a main function, which is the main entry point for everything up, right? Similarly, in Apache Spark, we have something called as Spark context. Without Spark context, you will not be able to do anything in Spark applications. So now Spark context will be sitting in the master machine and is very important component in Apache Spark. So every application of Apache Spark requires this Spark context, because without this, your program will not be executed. Your Spark application you will not be able to execute. As you can see here we have Spark context. Now after that, as in Hadoop, if you already know, we have a cluster resource manager, right? For example, Jan. That is what we have seen here, cluster manager. And after that, whatever code you are executing here. So let's say this B1 block, as you said, I'm going to execute into the memory, right? Let's say you're doing processing. So where you are executing it, in memory also there must be a place where you're doing all those things up, right? That space is called your executor. Now, the operation what you are doing on B1 block, let's say you are converting to uppercase. This thing is called as task. Means the operation what you are performing on that particular block which is sitting in memory is called as task. You can also cache it, because once your action completes, these blocks get removed from the memory. So if you want to make it stay for longer, you can also cache it. So this is what being shown here. Now this data nodes are nothing but your worker node that's being called in your Spark word. So you can call it as a worker node as well. So this is how the architecture of Apache Spark looks like. Let's talk about Spark streaming. When we talk about Spark streaming, in Spark streaming we will be performing the real-time analytics. So here we are going to perform analytics as and when we are going to receive our data. So immediately we are going to receive our data, we are going to perform our Spark. We can do it with respect to our Spark streaming, all our analysis. So what happens here is, let's say you are going to get your input data stream. Once it goes to your Spark streaming, it will be getting converted to your batches of small input data. Because let me ask you one thing. Let's say if I want to do a real-time processing, and let's say that real-time processing is a word count example. So let's say A came. So what would be your output? A comma 1. Now let's say B came. What would be your output? B comma 1. Because you're doing word count. Let's say A came again. Now what would be your output? A comma 1. Now, do you think this kind of word count make any sense? Because we are always outputting comma 1. No, right? It do not make any sense to it. Now, what should be our best approach? Best approach could be, how about if we wait for at least 5-10 seconds, maybe 10 seconds, and in 10 seconds, whatever data we collected, then we do some processing on top of it. Rather than immediately getting the data and start doing processing. Rather than doing that, how about we collect the data and then do the processing? That is what to be considered here, right? Because otherwise, my processing even is not making any sense. So let's say in 10 seconds, I collected this data, A, B, A. In that case, my output will be A comma 2, B comma 1. Now, this make at least some sense to me, right? Because in 10 seconds, at least I'm doing some processing on some data. That is what we are going to do in our Spark streaming. So though we can perform real-time analysis, but we generally do not go for real-time processing because it do not make any sense. So what we do is we perform a near to real-time processing. Not exact real-time processing, but we perform a near to real-time processing. That is what we always want to perform. So what we do is we collect batches. So let's say for 10 seconds, whatever data we collected, that will be like one batch. So this is what being denoted by the batch here. Okay. So you are getting the input data stream by Spark streaming, you're getting the batches of data, and then you are processing it with respect to your Spark engine. So again, the output will also be a batch, because again, let's say this is one output for 10 seconds. In next 10 seconds, maybe you have done some other way. So that is the other batch what you will be having. So this is what being shown up here. Okay. That's very important to remember. So that how in Spark streaming you will be doing everything up. Now this whole set things what you're getting in the batches is called your D stream also. Okay, that's one term which is being used. This is called your D stream. Now, moving further. Now in Spark streaming you can get the data from various sources. You can get it from Kafka, Akka, Parquet, you know. Now you can also get it from HBase, MongoDB, Parquet, again MySQL and all. So you can get it from multiple sort of data sources. So you are getting it from streaming data sources. As you can see, Kafka is already a streaming resource, right? If you already know about Kafka, it's a messaging queue where everything gets streamed already. So you can get it from them or from static data source like MongoDB and all. Now you are getting the data, you can process it using machine learning. You can do it with machine learning. Now whatever data you're getting, you can also perform it in Spark SQL. So all these things you can combinedly use. And then when you get the output, you can store it back to HBase, MemSQL. Again, Kafka, you can use it, or Elasticsearch. Anywhere you want to store it, you can do it after performing the processing here. how the steps looks like in Spark streaming. So in Spark streaming, what happens? You are, let's say, getting the data from your input sources, and then you are storing it back to your any of your HDFS database or dashboard. Now your input data stream, what you're getting, so you're passing it to Spark streaming, you are getting a batches of input data and just again more kind of fine graining it. Okay, this is the same thing what we have seen in the first block, just that we are again kind of fine graining it. So again, here what happens at a very high level, we are getting the batches of input data. Same thing what we discussed, like in 10 seconds we are collecting data, passing it to Spark engine and getting the output. Again, let's fine grain a little more. What is happening in your D stream means, let's say here, what is happening here? So here, let's say we generated one RDD at the rate of time. You can take it like with that example that in 10 seconds, let's say we collected A, B, something like this, right? Now with this, let's say we got in this time frame. Let's say in another time frame we got B, A. Let's say this is the data what we got here. So this is another RDD at the rate of time 2. All this together is called a D stream, but this will be kind of getting into batches and doing the processing. Now let's go in the fourth block, and you see we are again kind of explicitly kind of more doing more fine grained control here. And if you notice here what we are doing, this is my input stream, this is my output stream, because we are doing processing on top of it, right? So we are giving the output like A, 2, B, 1, right? So we are doing this kind of operations now. We are kind of performing some other, we are again fine graining this thing. So again, this is the word B stream what we are getting here. Okay. So this is how you will be performing your Spark streaming. So this kind of give you a very high level picture of how we can perform Spark streaming part. Moving to Spark SQL. As I said, Spark SQL is mostly for the people who work on the SQL side programming. Now in Spark SQL, if we talk about it, you can talk about Spark SQL, Spark plus SQL. It is going to become Spark SQL. You can use your semi-structured data or your structured data, but you cannot use it on your unstructured data. That's one of the restrictions which you should keep in mind. Now, Spark SQL features, it can support multiple sort of data formats like Parquet, JSON, Hive, Cassandra. And now here you are kind of doing operations on your different RDDs and shuffling and transforming and giving the output. We will see some queries of it. It will become more clear. Okay, let me give you an example of it. That would be better. Till now, what we were doing. Till now, when we were splitting the data, let's say we said that, okay, these are, let's say, my two data nodes. This is my block B1, this is my block B2. So this when I was pushing to my memory, I was calling it as RDD. But now, when I'm working with Spark SQL, I am going to work on a tabular format. Means what? This time, when I say I'm going to work on tabular format, I'm also not going to have only the data here, but I'm also going to have some rows. For example, let's say name, age. So it is going to have some rows, column as well as rows information. So that is one thing which will be there in your Spark SQL. So it is little different from your RDD. In RDD, we never used to have column information. But when we keep the data in our Spark SQL, though we are going to keep it in the memory only, but again it's going to have the column information as well as row information. So question from Nitin that, so this kind of data I'm also going to keep it in my other machine? Yes. So it is going to happen that this B1 block is also of this type, B2 block will also be of the similar type. Okay. Now this data again we are keeping in memory only, but only information in difference is that it is going to have even the column information along with your row information. That is the major difference here. Now, since it is different than your RDD, we will be calling it as data frame. We are no more going to call it as RDD, we are going to call it as data frame. So that is one thing which is a difference with respect to your Spark engine. So here we are going to use data frame because I'm also going to have my column information along with my row information. So here my performance and scalability is also very good when I compare, let's say, Spark SQL with Hadoop, as you can see in this example as well. That here if I do it with Hive systems and all, or with respect to MapReduce, it is going to be in fact very much time taking in comparison to Spark SQL. You can easily make out from this diagram. Red color is the performance with respect to your Hadoop systems. Blue color is with respect to your Spark SQL system. And it's very simple. For connection, you only use JDBC or ODBC connectivity, so you can use that. Now, again, here it's very simple. Now, let's say if you have a new functional requirement in Spark SQL, because you are using Spark SQL now. Let's say a kind of thing came up where you don't know any syntax for it. Like we don't know whether to use select or what we can do. You can create UDF also in that case. You can create UDFs and also work it, just like very similar to Hive, how you can do that, right? So if any function is available, you can execute that function. But if it is not there, you can create a UDF. What is UDF? It is user-defined function. In user-defined function, you can create a kind of code which will act like a API for you later. Okay, so that is what you can do as a user-defined function. Very similar to how you can do in Hive, you can also perform it in your Spark SQL. Now, so if I see this flow diagram, how it works here. So in this case, I'm going to get data from multiple sources. When I get the data from multiple sources, I'm going to convert it to my data frame API. Now after that, I'm going to kind of optimize it, interpret it with my interpreter because I'm doing the processing here. And then I'm going to pass it to my Spark SQL service engine and get the output. So this is how at a very high level, you will be executing some Spark SQL things. Now, let's move to MLlib, which is a machine learning library. When we talk about MLlib is going to contain two types of algorithms. One is supervised, second is unsupervised. What is supervised? What is unsupervised? This is a kind of a machine learning topic for which you need to know some sort of machine learning. But just to give you an idea, and let's say I have some data like this. Let's say experience is given for a person. Let's say his age is given for a person. His salary is given for that person. Let's say you are given this much of data set. Okay. Now, in this case, let's say you have some data available. Let's say when experience is, let's say 10 years, age is, let's say of that person is 30 years, his salary is, let's say 40K. Okay. I'm just giving an example. I know that's very small salary, but I'm just giving an example. Similar way, let's say more data is there. More data is there. Now, what's going to happen? In machine learning, you are going to have your algorithms using which you are going to make your algorithm run. That is called training. In training phase, what you're going to do, you are going to learn. That learning will be with respect to some rule. For example, if my experience is this, age is this, salary is this. If this is this, then my salary is this. Something of this sort. We're creating some sort of rules here. Now, in this case, when I'm creating some sort of rules like this, now, in this case, whenever, let's say, a new data came up, let's say somebody came up that I have experience of 9, my age is, let's say, 40. Now, I to have no details about his salary because I have already trained my data set, I have generated some sort of rule with respect to this, I will be able to predict this salary. It may not be an exact salary, but I will be able to do some prediction about the salary. That I have already created this rule, and from this rule I can see that this person is, let's say, going to make this much of salary. This person may be getting this much of salary. So this sort of thing is called your supervised learning. Unsupervised learning, where you do not have any detail, let's say, about salary. Okay, you want to find out something unknown. Maybe you want to find out the cluster. Maybe you want to find out which sort of clusters are falling into this category, which sort of cluster falling into this category, something of this sort. That is called your unsupervised learning. So that is the thing. There are a lot of algorithms here. In supervised, we have like name-based, SVM, regression, we have linear logistics and all. So this is the kind of algorithms what we have. Now, so let's see some examples. Now, like we just discussed about clustering example anyway. Similarly, we have classification. So everybody must be using Gmail box, right? In Gmail, you must be noticing that we have a spam email box. How Google decide that it's a spam email or a non-spam email? This all thing you can perform by using your classification. Where your output can be in a true or false manner, that thing can be your classification. In clustering, as we just discussed in the last example, let's say it's an unsupervised learning, where you want to you don't have any details about. For example, you must have used Google News, right? Now in Google News, what you can do is, in Google News, let's say you put something in your box and it let's say you say that Yuvraj Dhoni partnership, right? Then it starts giving you various news of Yuvraj Dhoni partnership from various sources. This is a grouping of all the similar kind of news, creating a cluster of similar kind of news. This is done with the help of clustering. Collaborative filtering, this is mostly to develop your recommendation engine, just like how your Amazon is building your recommendation engine. Let's move to GraphX. When we talk about GraphX, like as I said, if you know this Google Map, right? That can be one example of GraphX, where you solve the problem with the help of after generating a graph. Now, in GraphX, what happens? There are two important things. One is vertex, one is your edge. So let's say if I talk about from Facebook point of view, let's say there are two people, Sam and John. So they will become your vertex here. And let's say there's a relationship between them. That will be called your edge. Let's say the relationship between them and is that they are friends. Okay. So this is a relationship between them. Now, second sort of thing which we can define is a director graph. In this case, I don't have any sort of direction. But let's say here I have a direction. So in Twitter and all, you might have seen, right, that you can follow someone, right? You can follow someone to follow the tweet. So in this case, we can say that though they are friends, but Sam is following John. Okay, he is following John, and they have a relationship like this. So again, to understand all this graphics and MLlib and all those topics, you require some sort of knowledge in that domain. Usually, we provide all these details in our sessions only in detail. All those things you go, because right now we are just covering it as a brief about all the topics, but these things are done in detail. So I'm just giving you a high-level overview of all the things, friends. So let's go with the same flow with graphics part as well. So let's see a triplet view. Triplet view kind of like will show you a relationship here. Okay. So like we can generate even a triplet view, like we have vertices, we have edges here. Here you can see triplet is going to kind of denote the relationship here between A and B. Now similarly, we have property graph here. Now here you can see that we have vertex property, we have edge property, which is happening here. Right, so we can define all that up. So this is for your graph parallel computation, which is very useful. You can see this example here also, like let's say Alex, which is at the vertex, his age is 28. Now there's a relationship between 2 and 1. 2 is got Bob, who is of age 27. Right, so there's a number also attached to it in the edge. That is called your weight here. So that is what we are defining here. Now similarly, you can see one example of it. If you see, let's say we did some computation on top of it. And after that, what we are doing, so we want to display the name and ages of all the people. So let's say we want to display David is 42, Alice is 28. See this output. That is what we want to do. So we can do it with the help of our graphics. So we are going to have two things: vertex RDD. Vertex RDD will be this one, 2, 3, 4. We will also be having an edge RDD. Edge RDD will be created like this directed graph, which is there, right? This arrow one. So you are going to create one thing, and using that you are going to generate a graph. And then you can output it by using case classes now. Now in triplet relation, you can kind of figure out the relationships, as I said. So here, like Bob likes Alice. You can see this part, right? So Bob likes Alice because Bob is following Alice. So this thing you can do it with the help of triplet. So there's a triplet API. Using this, you can achieve this. Now let's see a very interesting use case for analyzing the flight data using Spark GraphX. So let's see this. So in this example, what we are going to do, our problem statement is that we want to do a real-time flight data using Spark GraphX, and we want to kind of visualize this also in the end by Google Data Studio. What we want to do, so we want to, let's say, compute the total number of flight routes, how many flight routes are there. We want to compute and sort the longest flight routes, okay, which are the flights which are kind of going longest. For example, maybe some flight may be there which is flying from India to US directly, no stop in middle. Maybe that may be a longest flight, right? Actually, there is a flight from New Delhi to New York, right? So that's kind of very long flight. So maybe we want to find out which are the longest flight routes. We want to display the airport with highest traffic, right? So which airports are very busy kind of airports we want to find out. We want to list the most important airports. That's what we want to find out. We want to list the routes with the lowest flight cost. That is also we want to find out. So where we are kind of having the lowest flight cost, where we get the cheaper flights, that is what we want to do. In the end, we will be using a Google Data Studio to kind of visualize our result as well. So this is how my data set look like, which will be having day of month, day of week, carrier code, unique ID, flight number, what's the delay, what happened for them, arrival, what's the distance they travel. All those details are mentioned in this data set. That is called my flight data set. Now, how my flow of diagram will look like? I will be having a huge data set. I'm going to store it in my database, storing real-time flight data set. So it's going to be stored in my database. Then I'm going to generate a graph from it. After generating a graph using GraphX, I'm going to query multiple things. Like I want to compute the longest flight routes. I want to calculate the top busiest airport. I want to calculate the routes with the lowest price. Then we will be visualizing our result by using Google Data Studio, and this will be our final result. How we are going to solve it? First of all, we need to import all the libraries. Then we will be creating a case class to kind of bring everything together. This is going to act like a setter method. Now, after that, we are going to pass the string pass by function to pass the input into the flight class. So we did this. So we have also made sure that we converted all the double to a double type, integer to my integer type, long to the long type. Now this is just the execution. If you will be executing in Spark shell, you can execute it like this. Now, second thing is, now we are going to create edge for our graph mapping. So what we will do, we will be loading this RDD data. Gaurav is asking one question. So we will be learning all this project in the sessions. Yes. So that's one thing which is going to happen. So right now, since it's just an overview of the whole thing, so that's the reason I'm not going in deep. But generally, in the session itself, your trainer will be teaching you all these things. Question from Nitin. So in that case, will I be getting more similar kind of projects? Yes. So we are going to have like more than 8 to 10 projects sometimes in courses. So there are so many projects which you will be given to solve it up. Question from Anil. So if I'm stuck, then what? Don't worry, Anil. We have a 24/7 support where you will be getting assistance if you are getting stuck at any moment. You can also get assistance from your trainer also directly or from your support team. 24/7 support, doesn't matter in whatever time zone you are sitting. You will be getting your support for that. You have to just call the support team or just drop an email to the support team and you will be getting an immediate response from them. Okay, that's what happens if you get stuck. And you can also talk with them. They may call you up if you face much of the issue. All those things they will be doing. And the support team, when I talk about, they are technically smart people. Awesome. Okay, great. Good to hear that. So now we are passing this data. See, we are passing this data into, we're creating an RDD out of it. Then we're creating an airport RDD with the name and ID column, right? Similarly, then we created the edges, we created the route, right? All these things we perform. So the same thing is getting executed here. Once we execute all these things, we want to create our routes and edge triplets. So you can see that we are generating a graph now with respect to my vertex and edges. We are now finding the number of airports. So we can use this num.6 to do that. We can also calculate the total number of routes by using GraphX by using number of edges. Now we can also calculate those routes with distance more than 100 miles. Means whatever flight is going to have distance more than 1000 miles, we can just execute that. We will be also implementing our edge triplet. Now after that, we can sort and print the longest route. So this is how you can do it. This is just the execution part of it. Can you see this part? We are seeing the longest distance. That distance is 4,983 miles, which is from HNL to JFK, right? So that's what's being shown here. Now similarly, you can also perform your vertex degree computation, where you can also find out all the airports with ID between this and this. Let's say you want to find the airport with the highest incoming flights, you can do that. Highest outgoing flights, you can do that with the help of the, again, these are the outputs. You can see that these may be my highest input flights, highest output flights. Okay. Now, similarly, we can also perform the page ranking of our graphics. So we are calculating the page rank, and based on that, we can do now the sorting of airport by ranking. Okay. And in the end, we are going to display the most important airport. Again, this is the execution of all that. Now, we can also have your Priggle computation, so where you can also implement your Priggle, and you can find the routes with the lowest flight cost. You can find the airport with the lowest flight cost. You can also display the airport port along with the sorted lowest flight cost. So all these things you can do with the help of this example. So this is done with the help of Priggle. Now, in order to visualize using Google Data Studio, this is just a third-party tool. You can use it to visualize and kind of see more, because right now you are looking at all the output in console. What about if you want to get a kind of a UI view of it? So you can do it with the help of Google Data Studio. Okay. Question from Gaurav. I can use anything else other than Google Data Studio? Yes, why not? It's just an example we have showed up. You can use even other tools as well, which can help you to visualize. As you can see, this is all about the visualization. We can see easily that what's happening, what's the variable, what's happening and everything. So let's see this execution in our Eclipse. All the things we will see in our Eclipse, all this execution part. Great. Okay, so let's move and see this project running in our Eclipse. Okay, so we have just now understood all these things here, like what we will do in each step. Now let's execute it in our Eclipse. So let's go to our VM. So this is our VM, which you will be getting from Edureka. Anil is asking questions. So we are going to get all this from Edureka. Yeah, Anil, I was just talking about the same thing. So you're going to get from Edureka. Question from Amit. So everything will be pre-configured here, or I need to configure it? everything will be pre-configured, Amit. So you need not worry about that installing Hadoop, installing Apache Spark. Everything will be pre-configured. Even the Eclipse and everything will be provided to you. So that will not be a problem. Okay, great. So let's move. So as you can see, even the Eclipse is provided to you here. You need to open that, double click on it. You will be able to open the Eclipse. I have already opened it for you, this project. So let me just open that. So we will be executing this project from my Eclipse itself. Now what we are going to do for this? So first of all, notice this is the same whole source code what we have understood. We have imported our library, then we created our class for airport. Then inside this we are doing the parsing. See the same step, right? Now after that, once we have done that, we are creating our RDDs for edge RDD and all. Then we are computing these queries, find the total number of airports, total number of routes, calculate the routes with the distance 4,000 miles, all the same steps. We are going to do that. Now you can execute it one by one line also. Maybe if you wish to, you can do it query 1, query 2, query 3, or you can execute everything together. Anything is fine. In order to execute, it's very simple. Do a right click. Once you do a right click, go to run as Scala application. And in your console, you will notice this execution will start. Let's see this. The query output will start coming up in your console itself. Right now there may be too many outputs because I executed everything together, but for your case you can just do it one by one query. So here it is going to just getting executed. Let this happen. Still running up. It's a big data also, just to let you know. The data is huge what we are using here. You can see the output coming up now. You will see this black color output, right? All this black, since it is continuously executing, it's very hard to see the output because it will. Now let me stop this. Can you see this output, black color outputs? It is telling that what is the distance and all those things out, right? So all these outputs will be showing up to you. Right now, since I've executed all the queries, it's very difficult to kind of see all the outputs. But you can say once you will do it one by one after commenting all the other queries, you will be able to see all this output one by one. So this is all you will be able to perform with respect to this project. Now let me come back. Congratulations for successfully learning Apache Spark, how you can do the real-time processing. As I said, this is just an overview of how you will be using Apache Spark, because definitely when you do it with Edureka, it's a long course, right? It's not, we cannot do it in just 1 or 2 hours there. So right now we just give you an overview so that you get an idea what is Apache Spark and how things are in this, and how this is so powerful in today's job industry. So, but this is just an overview to give you an idea. So I hope that all of you kind of enjoyed this session. Hope to see you in Edureka sooner on all these sessions. So maybe you can join Edureka sessions to get more details. This will definitely help you to boost your career as well, because right now Apache Spark is the next big thing which is in the market. So this is definitely a useful technology to learn. It is one of the hot selling cake because so. Again, thank you everyone. If you have anybody have any question, you can ask me up. So in Edureka, we can join any session. Yes, you can just talk to your support team, and they will be able to assist you that what is the next scheduled session. You can just go ahead and kind of do it. Okay, wow. So Amit is saying that he will definitely be joining these sessions now. Support number, you can just give up, you can just check from Edureka site, you will see a support phone number. Also, you can drop an email to support@edureka.in. So you can drop an email also there. They will be responding to you on your query. Wonderful session. Okay, thank you. So thank you everyone. So I hope that our path means once again, maybe I hope to see you in my sessions or in other trainer sessions. So thank you everyone.
I hope you enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply to them at the earliest. Do look out for more videos in our playlist and subscribe to our Edureka channel to learn more. Happy learning!